Welcome to this is Magic, we're learning physics together is magical. I'm doing question 40. So you got ratio behind T of speed V of raindrop. So this is about raindrop Vt. 0, it looks something like this. So this is the graphical form of terminal velocity on raindrop. So raindrop achieving terminal velocity means it reaches a constant velocity and start falling with that constant velocity. State the ratio with time of the acceleration of the raindrop. So they want to know the variation of acceleration with time. Okay, so let's take a few questions like this. So what do you need to see? As we mentioned earlier on, you start with the first thing. At time t equals to 0, A is equal to G. Beginning, there is no air resistance, therefore your acceleration is still the same, doesn't decrease or doesn't begin to decrease yet. Then you mention as time increases, acceleration decreases. And then at a time where decreases, what happens after that? So you can say then acceleration equal to 0 or goes to 0, let's say goes to 0, and terminal velocity is achieved. Okay, as I mentioned in the previous video, this is what we mentioned, but here they only want us to discuss about acceleration. We start with A equal to G, decreases, then 0, then end with terminal velocity. So the next question, what do they ask here in B? You have a second raindrop, has a radius that is smaller. So you got second raindrop. The thing happened here is radius becomes smaller. That means you got smaller raindrop. Sketch on the variation of speed with time for this second raindrop. So it's smaller in size. What happens to this graph? So if you were to plot this, remember initially, no matter the mass, they don't experience air resistance. So the beginning part is always linear. Step 1. Okay. Step 3, there's a moving too faster. It is a smaller raindrop. That means it will not achieve as high terminal velocity as the earlier one, but it will achieve it way earlier. So let's say I put it here. So step 3, you got terminal velocity. You're going to have it happen earlier. And after that, you just continue with step 2 with the curve. So you got a straight line here, followed by a curve. So this part is your step 2. So step 1, step 2, step 3. Step 1, linear. Step 3, linear. Step 2, curve. And this one will be, and label it as B. Okay? Some of you might ask, how come the terminal velocity is less? Imagine an object smaller, therefore it reaches terminal velocity earlier. In order for terminal velocity to be higher, it needs to have fallen more. But if it's small and achieves terminal velocity earlier, means at this rate, this terminal velocity, when it reaches this velocity, it already starts constant. Bigger object takes a longer time before your air resistance balances out the weight, and therefore then it falls with terminal velocity. That's why a bigger raindrop achieves terminal velocity later therefore its velocity is higher than this one here. Okay. So I hope you understand this video. If not, please replay this and provide me with some feedback.